Hi, so in this class of cloud computing, today we will continue here with the architecture of your platform as a service model. So, in the previous class, we have just studied about the reference architecture for platform as a service. Now we know that this architecture is comprised of two layers here, communication layer and the management layer. So we have covered here the management layer. So today we will start here with the communication layer for your platform as a service. The management layer, as we know, that is responsible for managing and provisioning or monitoring the complete platform as a service here. So the communication layer is responsible for meeting the requirements such as the availability, reliability, and optimization needs for the applications which are running on the cloud system here. So this layer here is communicating with the virtualized infrastructure also and with the platform as a service management layer also. So for this communication layer here, first of all we'll draw here a diagrammatic representation so that we can know that what are the various components here. So now this is communicating here with the upper higher layers like your software as a service also. So that basically consists of the cloud hosted applications here. So here we have certain components of your this layer, communication layer. So now this is here like this, and here we have the virtualized infrastructure. And here we have the management layer. Management layer here. So the various components which it has. Load balancer, then we have here messaging, then security, then we have other components here like your cloud service, orchestration, then cloud service interaction, caching. So these are here the key components of your communication layer. Load balancer, messaging, securities, cloud service orchestration, cloud service interaction, and then caching. Now we will study here these components one by one. So now the very first which we have here is like your load balancer. So that means here it is responsible for balancing the traffic load or the service load here on the cloud system. That means the load balancer here is responsible, or it keeps here the tracks of all the application services and the number of requests which are being served by these applications. So that means first of all it here keeps the track of the various application services, and then it sees the number of requests which are being serviced by them. Now, this monitoring here is responsible for balancing the load. So that means when it is checking the application service status, the number of requests being served, so it here handles the availability, reliability, and optimal usage aspect of the services. So we have been we have studied that communication layer is responsible for meeting these requirements. So with the help of load balancer, this load balancer here is able to handle these key parameters like your availability, reliability, and optimal usage of your resources. So by keeping this track, it can balance the load of the system and can check the availability of the application or the services now, or it can keep the track of the new requests here, then reliability. That means when request is made, some services are running here so that the requests can be served here, and the optimal requirements of the various resources according to the application here. So this is the very first component here for your communication layer, which is providing there the key parameters, serving the key parameters here for your communication layer. Now, the next one is cloud service interaction. Cloud service interaction. So, cloud service interaction. Now, since various services are deployed in cloud, now these services which are deployed in the cloud, they don't have a permanent address, as they might move from one virtual machine to another virtual machine. So that means here is a requirement for a component in platform as a service which knows that at a given point of time where all of these service instances are running. So that means if we have different virtual machines, they will be having different applications. So we're saying that they don't have a permanent address, that they will be residing on one particular virtual machine. They will be migrating from one virtual machine to another. So to keep the track here, we require a component. So that's why we have here the cloud service interaction. So this cloud service interaction component ensures that the interaction with these services do not fail. They keeps the, or it guarantee the availability of the various services. Either they are moved from one virtual machine to another virtual machine here. So there are certain requirements for the implementation of this component here. So what do you need? First of all, you need here a reliable central registry of these services and their endpoint addresses. So that means you require endpoint addresses of the various services, and then what you require, a central registry for these services. So that means you require endpoint addresses for various services and the central registry here for that. Now, after that, you need here a service creator that creates services on increase in demand. That means if there are certain increase in the demand here, so it can keep the threshold also in check here. So basically, this uh, cloud service interaction component here is responsible for checking or ensuring that the interaction between the services never fail. They by guaranteeing the availability for the various services here. So this is the second component here, which is cloud service interaction, providing interaction among the various applications or the services if they are migrated from one virtual machine to another. Now, the third one which we have here is the cloud service orchestration. Now, one of the application service usage remains, uh, or we can say that one of the scenario for the application usage is that multiple services have to be invoked to compute a particular business process. That means if we have a business process, certain applications or services may be required to complete that. So that means certain services have to be invoked in that case. So under this, each execution is considered. That means each execution is done and it may be reused later when the process has to be restarted. So this is your cloud service orchestration here. That means if this is just for some of the application using scenarios. That means when you need to invoke a number of services here. So that means when you need to invoke a number of services, you required here some storage, cloud storage for this. So the requirement here for cloud service orchestration is that you require here a temporary cloud storage to store the immediate state of a business process so that it is saved and later on if it is required it can be reused here. Fine. So that's why what you require here is a temporary cloud storage so that it can store here the immediate state of a business process. So that means it is way or we require here a way to define a particular workflow and then to store that particular workflow so that it can be reused here later. Now, after your cloud service orchestration, the next component which we have here is the cache. Now, this is basically the common cache here for the entire cloud. The only difference here will be that, or the only difference here is that it may not reside on a single virtual machine and it could be here redundant to ensure maximum reliability of a cache. So this is basically here for the complete cloud system. So what it requires, the key feature for its implementation are that it should have the ability to cache objects in multiple locations. That means for distributed services are required for that. Then it should be here able to update all the cache and to configure those locations. So that means first of all it should be able to cache those objects in different locations, then to update them and then to configure them. That because we are talking here that this is here for complete cloud. So if it is for complete cloud, it should be able to maintain all those objects, all cache objects, then to update their locations and to configure their location here. So we have various components like your load balancer, cloud service orchestration, interaction caching. Then we are left here with the messaging and the security. Next one here is messaging. So it provides a reliable or it acts here as a reliable messaging component. So it is able to operate for multiple virtual machines. This component here is able to work for multiple machines here. Now it ensures that there is no single point of failure regarding the messages and services can easily communicate with each other even if one or other virtual machine fail. That's why it is regarded here as a reliable messaging component, because it's able to operate with multiple virtual machines, and it ensures that there is no point of for failure, so that the communication is flawless here. Now after that we have the security component here. So security is a key issue for any system. So depending upon the security policy of an organization here, it could be an identity service for own exclusive cloud here. So that means what you require here for this, you require here a federation engine that can here create security tokens based on the identity service interaction. So that means the security policy here, depending upon a particular organization, will be exclusively for that particular cloud. So you require a federation engine here that can create here security token, which will be based on the identity service interaction. After that, what you require is a cloud storage here. Cloud storage to store the identity information here. If that is inside the cloud, if this is inside the cloud, so they require a storage for the identity related information here. Now, after that, we have another component here, which is virtual machine management. Virtual machine management. Now, this virtual machine management forms the media management between the underlying virtualization layers. That means here we have the virtualized infrastructure. So here we have this virtual machine management, which forms here as an intermediary between the underlying virtualization layer. Now, it should be able to, or it should have here the ability to interface with multiple virtualization engineers, because this communication layer is communicating here with the virtualized infrastructure, and it is here communicating with the management layer also. So these are here the key components of a communication layer, which here provides the communication services, including the availability and reliability. So we have components like load balancer, balancing the load, service orchestration, interaction among various processes, caching, security, and messaging. So this was here about the platform as a service architecture. So this is all here for today's class. Thank you so much.